Hi, and welcome to the fourth of the series about special relativity. In this section, we will talk about the second postulate. So, the second postulate states that any ray of light moves in a stationary system of coordinates with the determined velocity c, whether the ray be emitted by a stationary or by a moving object. So, let's start with several questions. Is the speed of the light source irrelevant, and which reference frame is stationary? Well, in general, speed of waves are not affected by the motion of the source. As light is a kind of wave, the same should be true for light. On the left is a wave with a stationary source, while on the right is a wave with a moving source. As we can see from both pictures, once the wave leaves the source, it will propagate at a constant speed. The source's movement will have no effect on this speed whatsoever. Now, let's talk about stationary. So we have a few questions. Which reference frame is stationary? Well, the answer is there is no stationary reference frame. Moving on to the next question. When talking about the motion of the light source, which reference frame are we using? The answer is, if light has a medium, then this medium is a reference frame. If light does not have a medium, then we're not really sure. So, final question. How do we understand the second postulate? Well, let's go back to asking Einstein. So how do we explain the second postulate? In relativity, the special and general theory, Albert Einstein explained it like this. Suppose one beam of light is sent out from the railway embankment in the same direction where the train is moving. To an observer on the embankment, the speed of the beam is c. To an observer on the train, the speed of this beam is c minus v, where v is the speed of the train. But according to the principle of relativity, the speed of light should be the same whether the reference frame is the train or the embankment. Thus, we get an incompatibility issue. In the reasoning of Einstein, the sole purpose of a stationary reference frame is to provide a speed for light, so that we can use this speed in all reference frames. That is why the word stationary is quoted. Under this reasoning, the second postulate becomes, light travels at the same speed in all reference frames, whether the light source is moving or not. Here, Einstein's reasoning is wrong because he uses the first postulate in exactly the opposite way. The first postulate implies that all motions are relative. The observed speed, c minus v, is a direct result of the first postulate, while the same speed in all reference frames is against the first postulate. To summarize this video, Einstein used the first postulate the opposite way, so in his eyes, the second postulate becomes light travels at the same speed in all reference frames, whether the light source is moving or not. Many people may take this explanation as the second postulate. This discussion will be continued in the next section. Following will be the references that we have used for this video.